Today what we're doing is we are putting triangles on the coordinate grid. So we're going to try and find missing coordinates of the vertices of our triangle. So a couple things to keep in mind. Try to use the origin either as a vertex of the triangle or like center your triangle around the origin. So the origin is the point 0, 0 where your x-axis and y-axis intersect, and so that's a really easy point to deal with, so you want to try and use it as much as possible with these. Then you want to place at least one of the sides on one of the axes. So like we like horizontal and vertical lines, and the axes are just really making things a lot more easy to deal with. Try to keep the figure in the first quadrant. So this is the first quadrant where your x's and your y's are positive, because who wants to deal with negatives if you don't have to? And then try to use coordinates that make your computations as simple as possible. So like nice pretty whole numbers. Just a refresher, an x-intercept would be on the x-axis. It's a number, comma, 0. A y-intercept is on the y-axis. It's 0, comma, a number. And let's say I had some random ordered pair A, comma, B. That means I'm going A units to the right and B units up. So it's almost like I'm creating this little triangle. So if you have an isosceles triangle and you have an altitude of an isosceles triangle, the altitude is going to divide the side into two congruent parts. So this is an isosceles triangle. These two sides are congruent. So these two base angles are congruent. And if this is an altitude, these two triangles are congruent by angle, angle, side, angle, angle, side. And so by CPCGC, these two segments are going to be congruent to each other. So that would make this the midpoint. So the big idea is if you have an altitude in an isosceles triangle, it will bisect this side. So this half would be congruent to this half. Keep that in mind. Keep that in your back pocket. Okay, so what we're going to do is try to find this missing coordinate of this triangle. So I noticed that this triangle is an isosceles triangle. So remember we just talked about if this is an altitude, this point is going to be exactly halfway between those endpoints. So if A is the origin, 0, 0, and B is 2p, comma 0, that means the length of this whole side is 2p. And so that means that this half is going to be p, and this half is going to be p. So to get to point C, I'm going to go p units to the right, and then if you notice, the y coordinate is q, the next letter in the alphabet. I'm going to go p units to the right, and then I'm going to go up q units. So the ordered pair to represent point C is p, comma, q. I went halfway in between 0 and 2p, which was 1p, and then up q units. On this one, notice these tick marks are telling me this is an isosceles triangle. So I want to find the length of side RS. I'm going from the origin 0, 0 to point S, which is at 2a, comma 0. So this side is 2a units, which means this side is also going to be 2a units long because it's isosceles. Those are congruent. So the coordinates of point T, I'm going 2a units to the right, and I'm going 2a units up. So the coordinates of point T are 2a, comma 2a. Then I'm going to actually draw the triangles this time. I want to draw isosceles triangle RST with base RS. So I'm going to start at the origin, use one of my axes, the x-axis, as one of the sides. So I'm going to make this my base, RS, which means that T is up here. And this R is at 0, 0. And S can be found, well, if RS is 4a units long, that means I'm going 4a units to the right. So S is still an x-intercept, so its y coordinate is still going to be 0. But it's going to be 4a, comma 0, because I went 4a units to the right. And then T is going to be halfway, since this is an isosceles triangle. T is going to be halfway in between R and S. So half of RS is 2a, so this is 2a and this is 2a. And then I'm going to go up a certain distance. And I don't know how far up I'm going to go. I have no idea. So when I don't know the next distance, I'm going to use the next letter in the alphabet to represent that distance. So since I used A first, now I'm going to use B. So to get from R to T, I'm going 2A units to the right, and then I'm going up B units. So T is 2A, comma, B. And then finally, I want to find equilateral triangle EQI with vertex Q, which is at 0, comma, root 3b. So that means it's a y-intercept if the x-coordinate is 0. So here's point Q at 0, comma, root 3b. And then I have this equilateral triangle like that, EQI. And it says the sides are 2b units long. So this is 2b, this is 2b, and then this is 2b. So that y-axis is cutting that side in half. If this whole thing is 2b, this is b, and this is b. So if I always start at my origin, I'm going b units to the right to get to t. So t is b, comma, 0. Because I'm on the x-axis still. And then if I'm going from the origin to point E, I'm going b units to the left, which means that's going to be negative b, comma, 0. So I knew the whole side was 2b. This is half, and if I'm going to the right, it's positive. If I'm going to the left, it's negative.